Hi, welcome to this STAIR Tailored. I'm Sarah Powell from the University of Texas at Austin, and today we're focused on how we can use different models with the length model to show fractions. So the length model of fractions means that we have a length, and if that length can be divided into equal parts, it can be used to represent a fraction. Often when we think about a length model, the most important representation is with a number line. So here I can draw a number line, and if I label this number line, here is 0, and over here is 1, I could then place fractions on this number line. And my number line can always extend this way, all right? So it doesn't always have to stop at 1. But when I have my length model here, I can show that the length of 1/2 between 0 and 1 is about right here. And if I was thinking about the fraction 3/4, the length of 3/4 from 0 is just there. Now, speaking of 3/4, we are going to focus on that fraction, and we're going to look at some manipulatives that we can use beyond the number line that still help emphasize the length model of fractions. So let me show you a few different examples. So we were talking about the fraction 3/4, and it's always helpful to have the abstract form of that number written so that students can see that we're focused on the fraction 3/4. Now I could use my fraction tiles to show the fraction 3/4. Here is my whole, and I want to focus that that whole is divided into 4 equal parts. That's what the denominator is telling me. So I can show my 4 equal parts just like this. Now, why is this the length model of fractions? Well, I can assume over here that this is 0 on a number line, and then over on this part of the whole, that is 1 on a number line. And again, this could keep extending if we wanted it to. Now, I have a fraction that's divided into 4 equal parts, but for 3/4, I look at the numerator, and I only need to show 3 of those 4 parts. So here, I've shown the fraction 3/4 along the length model. Now, I can put those 3 1/4 pieces on top of the whole. I could also physically lay them here on top of the whole. Either are fine representations of 3/4. The representation of 3/4 that you don't want to do is this. That actually does not show the fraction 3/4. Now we have our fraction tiles, and they're a very classic manipulative to use with the length model of fractions. But we also have what we call the Cuisenaire rods. So with the Cuisenaire rods, here I could show, here's a whole, 0 to 1, and this whole has 4 parts in it. And for the fraction 3/4, I want to show 3 of those 4 equal parts. So there's the fraction 3/4. But the nice thing about the Cuisenaire rods is you can often show 3/4 in multiple ways. So here's a fraction divided into 1, 2, 3, 4 equal parts, and I can show 3 of those 4 parts. So this is also the fraction 3/4. The fraction tiles are nice because they're labeled and they're very consistent, but the Cuisenaire rods are a little bit better because they really challenge students to think about the whole, how many equal parts are in the whole, and then how many parts of the fraction that they need to show. So those are some examples of the length model of fractions, and we hope that you'll tune into a few other STAIR Tailoreds where we look at the area model of fractions and the set model of fractions.